Okay, so I'm just going to go over some of your homeworks from last night. So if we do number 1. So secant times secant minus cosine. So this is a big parenthesis in which the secant on the outside needs to distribute to both pieces. And this is really just a one-stepper, because after you do that, you end up with secant squared minus 1, which, if you look at your Pythagorean theorem, is exactly tangent squared.
Are you teaching?
Shut up.
Can you prove it?
All right, in number 2, it's very similar to number 1, so I'm not going to do that problem. Number 3 is a little bit different, but it's actually similar because it's the same idea as number 1, only opposite. So what I mean by that is that in this group we have cosecant squared, and in this group we have cosine squared times cosecant squared. But in both cases, they have the greatest common factor of cosecant squared. And when you have a greatest common factor, you want to go ahead and pull that out of your parenthesis. So cosecant squared. So what we do when we pull out a greatest common factor is we say, what do I multiply this times to get this first group? Well, since cosecant squared is already what's there, multiplying it times what here gets you exactly what you see. Well, you only need to multiply it times a 1. When it is already there, you don't have to do anything. Then we have a minus sign. And then we say cosecant squared times what here gets you cosine squared, cosecant squared. So now, what are you missing in this group to get cosine squared, cosecant squared? So you already have the cosecant squared, because that's what's going to originally multiply it. So you still have to multiply the cosine squared here. And close that group. All right, at this point, hopefully you have started to recognize your Pythagorean theorem. This parenthesis represents an exact Pythagorean theorem, and that Pythagorean theorem is sine squared. So this is sine squared, and it still is going to multiply times cosecant squared. And since these two things are exact reciprocals, then when they multiply to 1, which is what we were trying to prove.
But if I were your freshman baby?
All right, let's go on to, this is just a difference of squares. I'm not going to do that problem. This problem is another greatest common factor, so it's extremely similar to number 3. Number 6, I've actually done, that was in the last video, so I'm not going to do number 6. 7 and 8 I also did in the last video. So let's go on to the next page. All right, number 9 is a good problem to do. So let's do number 9. So in number 9, it's kind of arguable which side you think is harder. And I'm not really sure that this is one of those that has a good, real answer. So let's do this side, just to change it up. We usually do the left side, so let's do the right side. So I'm going to rewrite it. And At this point, I see a lot of cosecant, I see cosecant, I see cotangent, but in what I'm trying to end with, I don't see any of that. I see cosine, which kind of lets me think that if I had sines and cosines, that would probably be a good thing. So I'm going to change all of this to sines and cosines. So cosecant squared is 1 over sine squared. And cosecant is 1 over sine. And cotangent is cosine over sine. Well, this is actually looking pretty nice because now when I multiply this fraction, I have sine on bottom, and that's going to multiply this sine on bottom. It's just going to get me sine squared, which is already here. So I already have a common denominator. So if you want to rewrite this, you can. If you want to skip this step, that's fine too. Because the point I'm trying to make is that the common denominator is already there, so I can go ahead and add across the top. So I get 1 minus cosine x over sine squared. Okay, it's at this point that creativity kind of comes into play. If what you want is 1 plus cosine x, I see 1 minus cosine x. That seems good. But it's in the wrong place. It's on top. I need 1 plus to be on the bottom. So this sine squared is not something that's helpful to us at all. So what I'm going to do here is I'm going to take this and I'm going to think about what it is that I can write instead. Well, since I've got this cosine that's on top, let's write sine squared with cosine instead. So how do I do that? Well, I can use Pythagorean theorem, and I can change sine squared to 1 minus cosine squared, because that kind of looks similar to the top. So that's the bottom using Pythagorean theorem. I still have 1 minus cosine x. Now, before you get all excited crossing stuff off, make sure that you are crossing it off for the correct reason. I've talked about this before, but pluses and minuses really mess up a whole bunch of stuff. Remember that this is the group 1 minus cosine x, and this is the group 1 minus cosine squared x. While they are very similar, they are not in fact the same. So what is the same, though, is if you use difference of squares for this guy. So I can use difference of squares to pull this guy apart into the group 1 minus cosine x and 1 plus cosine x. So it's kind of like I've used the factored version for that. And on top I still have 1 minus cosine x. And so now I can see I can officially, legitimately cross off this for this, leaving 1 over 1 plus cosine x. All right, let's do I don't know. Number 12. Sine cubed x times cosine squared x equals sine cubed x minus sine to the 5th x. This problem, believe it or not, is really not that difficult. Doesn't matter which side we start on. Either way, it's the same single step. I chose this side because usually pluses and minuses are harder. Plus, it's got a minus sign, or it's got a raised to the 5th power, so I figure why not. Sine cubed minus sine to the 5th. All right, so let's look at this. Two groups. something minus something. Both groups have sine. Go higher than that. Sine squared, go higher than that. Sine cubed. So, sine cubed is the greatest common factor. So, sine cubed times what here gets you sine cubed? Well, it's already there. Multiply it times 1. Minus sine cubed times what here gets you sine to the 5th. Well, I've already got 3 of them. I need to multiply sine would make sine to the 4th. So sine squared would make sine to the 5th. Well, at this point, you're done because this makes cosine squared. I already have sine cubed. Exactly what I wanted.